Welcome to Maths for You channel, a past question on projectile mechanics from a Cambridge International past paper. An object is projected with a speed of 15 meters per second at an angle of 35 degrees above the horizontal from a point on horizontal ground. Find the speed and the direction of motion of the project at time t 2 seconds after the instant of projection. I put a little sketch of the projectile and the actual trajectory or the projection path. On the path, there is a point, that's an arbitrary point. Its coordinate x, y. The horizontal distance traveled is x, and vertical distance traveled is y above the ground. And at the initially, the speed is given 15 meters per second, and the angle to horizontal is 35 degrees. The speed can be divided into horizontal, vertical, because we're going to use it sweat equation, those two directions. So horizontally is 15 cos 35 degrees. So 15, sine 35 degrees. And the t equals 0. Okay. And then again, at the point x, y is 2 seconds. The point I could say p. Use the sweat equation. V equal u plus at. We are using vertically that equation. Vertically, g is minus because of the projectile is under the gravity. So the acceleration is the gravity. So it's minus. We are using up direction. So minus g meter per second squared, which is minus 9.8 meter per second squared. It hasn't been given. I just took it as 9.8 or 10, whichever we want to take it, but just 9.8 precisely, minus 9.8 meter per second squared. And after 2 seconds, the coordinate, this on the path, this xy, which we have taken it after 2 seconds. So if it's travel 2 seconds, the point it's reached, p, it's the vertical speed, which we don't know. We can find that it's 2 seconds after instance direction, speed and the direction. So let's see this speed. V equal 15 sine 35 minus 9.82. So we just use the same equation, the sweat equation, u plus at. 15 sine 35 minus 9.8. So this is, if you work out, use a calculator, work out, is 11 approximately, or very closer to 11 meter per second, but the value is minus because of the direction of the speed is not vertically upwards, it's vertically downwards, because it's sort of the path is coming down, not it, so it reached the highest points and coming down, the particle is coming down at the time of 2 seconds after that projection. So it's because of the minus, so it's coming down. It's a vector quantity, so negative. Therefore, the direction is downwards. So, and again, the vertical, horizontal speed will not change throughout the projection. So that is 15 cos 35. Use a calculator, that is 13.3 approximately. 11 vertically down. We need the speed, not the vertical speed or horizontal speed. They need the speed. So we work it out. So put a little sketch to explain. So V equal simply the horizontal squared and vertical squared or horizontal squared or vice versa. So 11 squared plus 12.3 squared. That is it come up as 16.5 meter per second. The speed is given. When actually give the speed, they ask you to give the speed. So technically speaking, the speed they ask you to find. Therefore, we don't need to worry about the angle. But if they say the velocity, of course, we need to use the angle as well. So velocity is a vector quantity. Speed is a scalar quantity. So we could, technically speaking, we could stop it with a 16.5 meter per second, but just wanted to go further in case the students interpret it as the velocity. I'm sure that the question is for velocity. Right, so I just put a little theta, downwards theta. So if you look at it here, the actual velocity is this way. So it's V. Tan theta equal opposite over adjacent. This is opposite 11. 11 over, or vertical over horizontal, 11 over 12.3. That is, this is 11 over tan inverse 11 over 12.3. You can work it out if you want to get the angle in degrees. Thank you. Please subscribe the channel and share the contents with your friends and other students. Thank you.